Hey everybody, Lars here. I always want to say live and in person, but it's not live, it's recorded. But it's contemporary, it's spring 2021, February 9th. And I thought I would chime in and say hello to everybody for the first time in person. You've been looking at the canned videos for the course. And because I can't do a video without doing some Python, we'll jump in. We're going to look at a while loop and a for loop and discuss some of the differences and some of the things that I want you to be aware of. But we're going to do that really quickly. I just wanted to jump on and say everybody's doing great. The first unit in this course, especially when it's fully online. In the past, it was a hybrid, and we would actually meet in person once a month. And then people would get to see each other, maybe form study groups, maybe do some different things. So it's a shame we can't do that, but fully online still works. You can still get to know each other via the discussions, which is why I have people post 3 days before the end of unit, so you have a chance to read each other's posts and a chance to do things. As you've probably wrapped your head around by now, Unit 1 is about process. I want you to understand. We have the readings in the book, the Zell book. We have the slides. I want you to read the materials, get used to it, maybe play around with a little bit of the exercises in the code and do all of those things. Then you have your discussion post, all right? Usually a TED Talk. Sometimes it's a small little book chapter or something like that you'll see as we go along. And you do your post so that everybody else can see. Then we get the review videos, and you watch the review videos, and they go over what you've seen in the slides. Regular units, Unit 1, Unit 2 are 2-week units. You're going to see Unit 3 is a 3-week unit. Then, after you've gotten your review videos, after you've engaged with the resources for a while, usually about a week before the end of the unit, like today, I think I shorted you a day, though. You may only get 6 days. I give you the assignments, and then you have the assignments, and then you can do the assignments, and the very last day of class, you have your quiz. Things are broken down so that you engage with the materials multiple times, but as you do this, you are taking on a different role. The first time, when you first get the slides and you first read your book, you're the learner. You are reading about these new things, discovering what to do, trying things out. The second time you're going to approach these things is after you've gotten your assignments, okay? Now you are a practitioner. You've gotten a commission. You've gotten something to do. So now with that framework, with I've got a task to accomplish, you're going to go back and look at the materials again, and you're going to figure out how to accomplish your tasks. Then when you get to the end of the 2-week process, you take a quiz. You have to report out. You're being asked questions. You're now the expert, okay? And you have to report out as an expert and explain why things work a certain way, why things do it a certain way, okay? So it's developed to engage with the resources 3 times, as the learner, as the practitioner, and as the expert, as you study at the end, to report things out, okay? It doesn't work if the night before you go, oh, I got to do this, and you try to do everything in 2 nights. This is graduate school. Are you clever enough to do that with Unit 1? Absolutely, especially if you had some experience beforehand. Unit 2, you're going to discover as you see the assignments, okay, this is, it's a little bit like a brain teaser, but I can do this pretty well. I'm okay. Unit 3 will rear its ugly head and crush you if you keep that attitude. You need to engage with the resources early, okay? And I know, I've said this a million times to a million different classes, and there's still going to be some people who wait till the last minute. You can do that in Unit 1, okay? That's about process. That's about getting used to things. Unit 2, depends, but sometimes people who have previous experience still find it rather simple. Unit 3, you will see. If you, the night before it's due, look at the assignment for Unit 3, you're not going to get it done, okay? I'm just telling you now. I'm giving you the warning now because I'm going to have to read the emails later, all right? So that's what I'm thinking when you get your material spaced out the way I space it out. Learner, practitioner, report out as the expert when you do the quiz, all right? All right. Because it's a Python video. I'm not doing a Python video without doing some Python. All right, my idle is big and huge because I go to Options, Configure Idle, and you can change things in here, okay? I do it big because I know I'm doing videos and I want people to be able to see. All right, what do I want to do? I'm going to go File, New File. Look at that. And I'm just going to say, what am I going to say? Playing around with loops. Because what I'm going to do is we're just going to code up a simple while loop. So let's say n equals 0. And while n is less than 5, we will print n, and then we will make n equal to n plus 1. I don't think this is the first time you've seen a compound operator, but if it is, that's the same as n equals. Okay, so when I run this loop, first I'm going to save, and I'm just going to call it test.py, which is fine for our purposes. And then did I run? Oh yeah, of course. The differences between Python 2 and Python 3 become apparent. And there we go. All right. Remember, even here, I started counting at 0. So 0, 1, 2, 3, 4. Okay? With my while loop. So that's what you would call a loop, where we definitely know it's going to go 5 times because that's what I said the condition is, and I control the variable inside the loop. And the reason I do a simple loop like this, I can also say, if I want to start at 1, I can do that. But then if I want to print that 5 out, I make n less than or equal to. And then when I rerun that, you see it runs. All right. I am not doing anything special when you see me make a change and really quickly it runs. All I'm doing is Control S to save, and then F5 to run. You can see the F5 runs your module, and the Control S saves. And if you look on your keyboard, it makes a little diagonal up your keyboard. And if you're a Python programmer, that becomes second nature. So you're just going to see it run, okay? Nothing in my hands, nothing up my sleeves. I'm just doing that key combination, and my code's getting run over there in the interactive window. All right? So now let's say for I, range, let's say 5. All right, we're going to have to space that out. My OCD is not going to permit that. All right, look at that. So now, remember, because we've gone over range, what are we really doing? We're really doing 0, 5, 1. I want to start at 0, and because this is an interval in Python, that's exclusive. It's the first thing I don't want, and I'm going to increment by 1. So when I run this, it's going to give me 0 through 4. Start at 0, first thing I don't want, up till 4. So if we want to go 1, 2, 3, 4, 5, like we've done right there, we can start at 1, go to 6. And then we go 1, 2, 3, 4, 5, because 6 is the first thing we don't want. Okay? So this points out a difference in Python that may not become readily apparent in other computer languages. And if you have no experience with other computer languages, that's great. I'm glad you're learning Python before you learn them, because I think Python handles loops and iteration more naturally than other computer languages. Another computer language, say a C++ or a Java or something like that, would do a for loop, and you would do 3 things. You would say, you would declare your variable and you would set it equal to 0. Then you would have your condition, like my while loop up there. I would say n equal to 5. And then I would say I equals I plus 1. Okay? And what would happen is you would have a loop, you know, of a command block of whatever, And that loop would run 5 times. It's called a definite loop. You'd set it to 0. You check that condition. Is that condition true? Okay, I'm going to run the loop. You'd run through the loop, and then you'd increment by 1. Okay? In other languages, for loops are just definite variants of whiles. All right? As long as a certain condition is true, keep going. The difference with Python, okay, and the way I'll show it to you is like this. The difference with Python is that Python truly iterates over a list. So now if I say for j in my list, okay, print j, I print, here it is again. All right, let's get this straight now. All right, we can see down here I do 2, 3, 4, 5. Is that, yep, that's the contents of my list. So you can see I have a list, and I just say for j in my list. And that is true what we would call iteration. I've given you a list of numbers. I want you to perform a task for every item in the list. So I print every item in the list. Okay? Here, when I've done this for loop up here that did the middle section, I basically run the range function in order to create a list from 1 to 5 and then print it out. So it's almost like I'm mimicking the behavior of other languages, and it's odd because Python does iteration differently, but then it goes ahead and teaches it the same way we teach it in other languages. This is the more natural occurrence. I have a list. I'm going to iterate over that list, and for every item I'm going to do something. That's what iteration is really about, okay? When we teach Intro to Computer Science at the undergrad level, we usually teach the while loop first, and then we'll teach the for loop as a variant. But in Python, they're truly different things, right? For loop is for iteration over a list, and we can use range to create a definite list of numbers and use our for loop for definite loops. The while is for indefinite loops. It's for when we don't know when that condition is going to be met. And when that happens a lot is with interactive loops, when you go into a loop and then you take user input. And depending on what the user inputs, you do different things. And sometimes that condition isn't true, so you get out of the while loop. All right? This is YouTube. Stop it. Code that up. Play around with it. I just want you to see some of the differences with other languages and why a lot of people, especially Python programmers, think Python is more natural. It's more going at what you're trying to do when you're solving problems in your head. Because at the end of the day, that's what computer science is about. It sounds weird to say it, and people always look at me funny when I say this, but computer science has nothing to do with computers. Nothing. It's about problem solving. But it's about problem solving with discrete mathematics. If you can solve problems in discrete, finite steps, and then take those solutions and offload them to a computer, well, computers do things incredibly quickly. Computers are dumb. They only do what we tell them to do, but they do things incredibly quickly when we tell them what to do properly. So if you can solve problems in a certain way and offload it to a computer, that's computer science. I was going to say computer science is badly named. It should have been called applied discrete mathematics, but then nobody would care about it and it would be interesting. But that's, at the end of the day, that's pretty much what it is. Okay? It's the codification of your problem-solving skills. All right? It's weird because at the end of the day, it's functional writing. Everything we did right there has a purpose and does something. Your entire life, writing has been for communicating, right? Now, all of a sudden, you're doing something different. You're writing, but it's functional. You're going to give something instructions, and it's going to do something. So you have to be precise, and you have to understand the language that that particular thing understands. I give talks to the freshmen when they come in, and I always say, I go, how hard is it for me to teach you how to make a sandwich? And they laugh. go, it's easy. You just, tell me how to do things. We have a lot of things in common. We speak the same language. We get hungry. We all do those things. Then I say, how hard would it be to teach a 3-year-old how to make a sandwich? Well, then it gets harder because then communication isn't easy. And then I'll say, on that beautiful day when the aliens land on College Avenue and come barreling out of their spaceship, how hard is it going to be to teach that alien how to make a sandwich? The alien hungry? Has the alien come to eat us? I still may have a fighting chance, though. The alien may need sustenance. The alien may have vision, and I can show them how to do things and this and that and this and that. And then I will say, let's say I have a hunk of metal with some electric running through it. How do I teach that how to make a sandwich? And then everybody looks at me, crazy-eyed, and I say, that's computer science, because that's what you're doing. You're teaching a machine with digital circuitry how to perform tasks for you. And in order to do that, you have to have a common language. So it can't be natural language because the computer doesn't understand natural language when we speak to it. The computer understands ones and zeros, but we don't understand the ones and zeros. It's very difficult to read and translate when we do. So we have to meet that computer in the middle, and this is how we do it with programming languages. With programming languages, they have to be precise, but we can take this code, and when the Python installed on your machine runs it, it turns it into those ones and zeros that the computer understands, and it runs your commands. And when it runs your commands, it then outputs it to this window right here. Okay? So to finish out, I'm sure I don't know how long I've gone, but I'm sure it's too long. Keep doing what you're doing. I think everybody's doing great. Okay? Engage with the resources early, especially when Unit 3 rolls around, because Unit 3 is going to be a 3-week unit with 3 distinct parts to it. You're going to learn about functions, you're going to learn about file I/O, and then you're going to learn about modularity and libraries. The homeworks for Unit 3 are going to be everything you've done so far, because if you've read the primer document, we take the first half of the class and I teach you Python. We're going to take the second half of the class and you're going to learn and you're going to do things with Python. Okay, so it's comprehensive, that assignment. Everything you've learned so far, because computer programming is like a pyramid, up and down, just like mathematics. What you learn the first week, you're going to use forever, and you're going to get used to it. Then you build on top of it, build on top of it. Remember when you were in school, you had arithmetic, algebra, geometry, trigonometry, pre-calculus, calculus, and you still used arithmetic, even though you were doing calculus, right? So we need to build that pyramid with our programming skills, and then we're going to work with computer science problems. All right, I'll blab all day if I don't shut up soon. So I'm going to stop, and I'm going to let you get on with your week. Keep doing what you're doing. First assignment came out today. Second assignment will come out tomorrow. I will open up the quiz on Sunday, which I believe is the 14th, and then the 15th all day long, and then 2 hours at the end of the day until 2 a.m. So you'll have 30 hours to do the quiz. And then Unit 3 will open up. All right? So the semester is moving right along. Absolute pleasure to meet you. And I will be doing more contemporary videos and chiming in and talking about Project Euler and the different things that we're doing as the class goes on. Okay? So be good. Keep doing what you're doing. And I'll talk to you soon. Take care. Bye.